In this video, we are going to talk about all things quadratic functions. So we'll be utilizing vertex form. We'll be utilizing completing the square, something we talked about previously. Also determining the function of a quadratic equation based on its graph. In your guided notes, let's go ahead and turn to page 283, and then we'll look through section 4.1 as part of the notes for this video. So in the first part of the notes, you'll have the definition of a quadratic function, and you can either write this down or you can take a picture of it. Essentially, you need to be able to recognize that any equation or function in this form is a quadratic function, since the highest degree is 2. And this is actually the standard form of a quadratic function. Some things that we should know from Algebra 2 and also Algebra 1, if the value of a in this function is greater than 0 or positive, then the graph will look something like this, maybe shifted to the side or shifted up or down, but this is the basic shape, the parabola. If the value of a of that quadratic function is less than 1, so it's negative, then it will open downward. So these are the two shapes that these are the two representations of the parabola that we should be familiar with from Algebra 1 and Algebra 2. You should also be able to determine whether or not a quadratic function opens upward or downward without using the calculator. So in this case, in this example on page 283, it says without graphing, determine whether the graph of the quadratic function f of x equals negative 3x squared plus 6x plus 1 opens up or down. So again, we focus on the leading coefficient, which is the value of a, and it's negative 3. And since it's less than 0, then we know the graph must open downward. And we can do that without a calculator, or if you struggle with that, you can also graph it as well. So this is on page 283. You can write that information down in your guided notes. Some things that we want to be able to identify for a quadratic function are these key features or characteristics. We want to be able to find the vertex, the axis of symmetry, the y-intercept, any x-intercepts or zeros, real zeros, and then be able to state the domain and range. So for the vertex, we know that's either the lowest point on the parabola or the highest point, depending on how the graph opens. And the axis of symmetry, that's the line that divides the graph into two equal portions. Y-intercept, x-intercept, those are pretty self-explanatory because we've been looking at those periodically. And then domain and range, that's also pretty self-explanatory. But the vertex, for this particular parabola, since it is opening upwards, the vertex is the very bottom point. It's considered a minimum value for this graph. And then there are two real solutions, or two real intercepts for the x values. And the graph does cross the y-axis in one place. And then this dashed line through the vertex is the line of symmetry. It actually divides the graph into two equal portions. And then, of course, we know the domain represents the x values, we know the range represents the y values, and we should be able to find the domain and range. This graph doesn't have any values, so we won't actually find it here, but we will find it later. So on page 284, you have these characteristics. You can go ahead and label that graph that looks similar to this in your guided notebook. On page 285, you have some blanks to fill in, so I've highlighted the information that should go on those blanks. We are going to talk about vertex form and how we can write vertex form from standard form. So a quadratic function is in vertex form if it can be written in this way. F of x equals a times x minus h squared plus k, where h and k is the vertex. And again, as a reminder, the parabola opens up if the value of a is greater than 0, and the parabola opens downward if the value of a is less than 0. And here are just two examples of a parabola opening upward and a parabola opening downward. Now, one feature you want to kind of notice is that the line of symmetry always passes through the vertex. So the line of symmetry is a vertical line, and it does have its own equation. And since it's a vertical line, the equation will be x equals, and then whatever the value that h represents in the vertex. So that'd be pretty easy for you to find the equation of the line of symmetry, because if you know the vertex, then you know the line of symmetry's equation, because it's just x equals and then whatever that number is, regardless if it opens upward or downward. And I know I'm moving through this pretty quickly. This is just the vocabulary part before we get into some problems where we will be writing the equation in vertex form from standard form and then vice versa. And we will need to be able to identify that key information. All right, so here's kind of our first real example of looking at a quadratic function and then identifying some information from that quadratic function. So example 2 on page 285 says given the quadratic function f of x equals negative and then x minus 2 squared minus 4. And so this is in vertex form. We want to find the following information. So I believe it goes from A to F, if I'm not mistaken. So when we look at the vertex form and we want to identify the vertex without graphing it, of course, we could just graph this in the Desmos or a calculator and figure out, what's the lowest or the highest point in the graph depending on how it opens. But since it is in vertex form, we can easily identify the vertex. And so here we see the vertex is 2, negative 4. Now, even though this is x minus 2, if this were a plus sign, then the h value would be negative. But since it is a minus sign, then the h value is actually positive. So we look at the opposite of that value when we want to determine what the value of h is. The value of k is exactly what it is in the equation. So since this is minus 4, then the value of k in our vertex coordinates would be negative 4. And then does the graph open up or down? Well, look at the leading value. So if we were to multiply this out as x minus 2 times x minus 2, that x squared term would be negative because of this negative sign when you distribute it. And so that makes the leading coefficient negative, which is less than 0, so it opens downward. And then what is the equation for the axis of symmetry? Well, remember the equation is x equals h, and since h is 2, the equation is x equals 2. So if I were to make a graph of this function and I were to draw the imaginary line that separates the graph into 2 equal parts, then it would cross the vertex or the x-axis at the coordinate 2, and so that's our equation. Something else that we want to be able to do is to identify the x-intercepts and also the y-intercepts from the equation. We can't really see the x-intercepts because we know we have to let the y value equal 0. So I want to let this f of x term become 0 and then solve for x. And to find the y-intercepts, I want to let the x value equal 0. Now you could graph it to see if the x-intercepts and the y-intercept is an integer. The y-intercept is, but the x-intercept is not. So in this one, we have to solve it by hand, especially if in the homework it asks for the exact value and not an approximate value. Let's go ahead and do that. We want to, in our function, we want to let the y value equal 0, and we just want to solve for x. So I've started solving it here, where I'm bringing the minus 4 term over by adding 4 to both sides. And then once I bring that over, that gives me 4 equals negative, and then x minus 2 squared. And I know that I need to get rid of this negative sign, so the opposite of multiplying by negative is to divide by the negative. And well, that gives me negative 4 equals x minus 2 squared, and the only way to get rid of this squared is to take the square root of both sides. Well, kind of like red flag here, since I don't have the square root of a negative 4, it's not a real number, that means my x-intercepts are imaginary. And I don't really need to find it unless it asks me to in the homework, which I don't believe it does. If it does, then I'll just help you with that. But I know that would be 2i, and I could plus or minus 2i, then I could add 2 to both sides. So that wouldn't be too difficult to find. But this also tells me another thing, that this parabola does not cross the x-axis. Since we cannot find real solutions or real x-intercepts, that means the parabola does not intersect the x-axis. To find the y-intercept, I take that same function and now I let the x value equal to 0. And so here I've changed f of x to y equals, and I've replaced the x value with 0. And this is just an evaluation. So you can either go through the process if you know your order of operations to get down this value, or you can plug the entire expression into the calculator or into Desmos and you can figure out this value here. But this tells me that this parabola will cross the y-axis at the point negative 8. And then lastly, we want to be able to sketch the graph. So here the graph is already sketched and I can see that this is the vertex, 2, negative 4. And here's the line of symmetry, x equals negative 2. And here's the y-intercept, negative 8. And it does not cross the x-intercept, so there's no real solutions. Now, for my domain, it's all real numbers. I know that as the parabola, it's pointing downward. So as it continues to go downward, it just gets wider and wider and wider. So it encompasses all x values. However, for my range, its highest point is 4, but then it just keeps dropping lower on the y-axis. So it goes from negative infinity, not included, all the way to all the way to -4 included, because it actually does touch that point. And so these are some things that you're going to be expected to find in your homework and also throughout the guided notes. So I believe we have 2 more examples that we'll go through this, but we're going to write an equation in vertex form, and then we're going to write an equation in standard form as well. So now we want to take a quadratic function that's in standard form, and I want to write it in vertex form. So I need to take this 2x squared minus 4x minus 3, and I need to write it so that it's in this form here, which is vertex form. And to do vertex form, we need to remember completing the square. And so I know that that was a topic that really wasn't our favorite when we looked at a few chapters ago, but it's coming back up again, and so we definitely need to know how to complete the square to do this process. Now there is a way that you can write the equation in vertex form without completing the square, and we'll look at that example as well. And so you can kind of decide which one you like better, and you can just go that route the entire time. So if you recall, to complete the square, this cannot be, the leading coefficient has to be a 1, so we have to take care of that. And then we have to do something to the middle term. So we'll re-talk about that. So if I want that leading coefficient to be a 1, that means I need to divide everything by 2 and then simplify. So that gives me y equals x squared minus 2x minus 3 halves. And I need this to be a 1 so that I can complete the square. And to complete the square, I need to take the middle term, which is -2, divide it by 2, and square that value, and I'm going to add it to both sides of the equation. In this case, it's not really going to be both sides. Well, I'll show you in a moment what I mean. So hopefully this is jogging your memory from what we talked about previously. So now that I'm taking this middle term, -2, I've divided it by 2, and I squared it, and I'm adding it to this part of the equation, or this part of my expression, because this is the part that I want to complete the square. But then I'm also going to subtract it, because this is like 0. Well, that shouldn't be a 3, that should be a 2. So I made a little bitty mistake, and let me correct that mistake. That should be a 2. There we go. Whatever I add it to the equation, I'm also going to subtract it from the equation as well. And when I said add it to both sides, originally, maybe when I was doing this before, I was thinking that I would add it to the same side as y, but I'm not doing that in this case. So we'll kind of just ignore this part and just focus on this. So now this part I can simplify, right? I want to be able to simplify the part in blue. And that simplifies to, this is 1. So -2 divided by 2 is -1. I square it, I get 1. And then the same thing, -2 divided by 2 is -1. I square it, and I get -1 because I'm subtracting that. Here I'm adding it. Here I'm subtracting it, so that's essentially 0, and that does not really change in the value of my function. It's just changing the way it looks. But this is now a perfect squared trinomial, and I can factor that expression. So this expression here can be easily factored because of completing the square. And so this is what I get when I factor it, right? X minus 1 squared, if I were to expand that out, will give me this back again. And this 5 halves is 3 halves minus 1. Because we know 1 is the same as 2 divided by 2, and 3 minus 2 is -5. Let's fix that again. And so now this is somewhat in vertex form. I'm not done yet, because remember earlier, I had to divide everything by 2 in order to get to this point. So I have to bring that 2 back. So since I divided by 2 earlier, to bring that 2 back, I'm going to be multiplying by 2. And so I multiply by 2 so I can get my original function back. And this is my original function that represents this graph here. If I were to graph this in the calculator, it's going to be wider than this one because I've divided everything by 2. And so that's going to it's going to compress the graph towards the x-axis because it's not, it doesn't have a factor of 2 in it. If you don't believe me, graph this in your calculator or Desmos, and then graph this, and you'll see what I'm talking about. But this is an equivalent form in vertex form of this function here. If I were to multiply this out and then distribute the 2, I'll get this answer back. So now I can take this information and I can answer those questions that we had earlier, like what's the vertex, does it open up or down, the x-intercepts, the y-intercepts, that information, domain and range, all of that. So I want to be able to answer these questions on page 287. So this is the function that we got. I want to find the vertex, so h and k. I want to determine, does it open upward? So is the value of a bigger than 0, less than 0? What's the equation of the symmetry? And how can I find the x and y intercepts? So I want you to do that information. I want you to do that, and let's see if you can find that. I also want you to find the y-intercepts. And then the graph, you don't have to really sketch it, but you can. So there should be a space for you to sketch it. This is how the sketch of the graph should look. And also this would be your x and y intercepts this would be your x-intercept that you would have found by hand. Also your y-intercept, and then your vertex. So hopefully you're able to do that information there. As far as the domain and range is concerned, the domain, similar domain to the previous example that we did together. The graph, since it opens up, it's going to continue to get wider and wider in both directions as it gets larger, as the y values get larger and the x values get larger. So we say the domain is all real numbers, or from negative infinity to positive infinity. And the range, well, the lowest part of the graph is -5, and then it just keeps increasing from there. So we would say that it goes from -5 to positive infinity, with -5 being included. So now we could talk about how we can find the vertex of a parabola without having to complete the square. So if you're like, I'm not really feeling completing the square, that's not really for me, I didn't like it before, I still don't like it, then instead you can use this equation here. On page 288, you should have a space to write this down. So given the quadratic function in standard form, the vertex of the parabola can be found by this way. Now this is actually the formula or the equation for the axis of symmetry, where the value of x is -b divided by 2a. And once you find that value, you can take that value and you can substitute it back into your function. So that's what this notation means, f of -b over 2a. And that'll give you your y value. And essentially you'll have the coordinates for the vertex, where this is the x value and then this process is the y value. So we'll look at that on the next example, which is on page 289. And I kind of have this already typed out because I don't want to make the video too long, but we can kind of look at the steps together. So on page 289, we have this function here. It's in standard form, -2 x squared minus 4x plus 5. And so instead of completing the square like we did before, I can use the formula to find the vertex, which is x equals -b over 2a. And so we have to be able to identify the value of b. So that's -4 in my equation. And in fact, if it helps you, because you may have to do the quadratic formula, I can write a, b, and c. And so we really don't need the value for c, but we do need a and b. So the value of b is -4, the value of a is -2, and so I'm taking the negative of this, and that gives me -1 as the value of x. And so I take that number and I substitute it back into my original function, and I get a y value, and that represents the x and the y for my vertex. So using this formula, I can see that the vertex is -1 and 7. -1 is the value that I found using the b and the a from the equation in this formula, and I take that -1, plug it back into my function, and I get 7, and so this is my vertex. To determine if it opens up or down, again, same information. Look at the leading coefficient. Is it greater than 0? Is it less than 0? What is the equation for the axis of symmetry? Well, since we have the vertex, that should be pretty easy for you to answer. The equation is -1, or x equals -1. And now what we would like to do is find the intercept. So again, I've taken the same information and I've kind of typed it out just to save us some time here. And this is the quadratic formula. So this cannot be factored. It's not factorable. So I either have one or two options. I could have completed the square, or since many of us like the quadratic formula, I can use a quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c divided by 2a. And so this is that process to go through to find the x-intercepts. Here we can see they are real values because the square root does not have a negative under it. You have either two options. These two are the exact solutions, and these two are the approximate solution. So you just don't want to rely on graphing it, because your homework may ask you for both. What's the exact solution, and then what's the approximate solution, rounded to a certain decimal point. And then we want to be able to answer those questions. We want to be able to find the y-intercept. We want to be able to sketch the graph. So this is the image of the graph, shows those two solutions that we found by hand, also shows the vertex that we found by hand, and then it shows the y-intercept. Now, for the most part, you can find a lot of the information by graphing. I could have graphed this initially and then found the vertex pretty easily, found the y-intercept pretty easily, but the one thing that I could not find easily would be the intercepts, because those are not integers. Those we kind of have to use a quadratic formula. I can even see the line of symmetry pretty easily as well. And then our domain and range, that's something that we should be able to state. Again, domain, all real numbers, because as the graph continues to go downward, it stretches in both directions for the x-axis. And then for my range, it's like the highest point is 7, and then every other value is below that. So from negative infinity all the way to 7, with 7 being included. So we should be able to state that. And this is a question that I want you to, for here, you should be able to answer this question. Is the leading coefficient positive or negative? So based on how the graph looks, do you think the value of A would be negative or positive? That hopefully you can answer. And then what's the value of H? What's the value of K? That's simply asking you about the vertex. So I can see the vertex is this point, and -1 is H, and 4 is K. So there we have the value of H and K. And we actually want to use that information so that we can write an equation from the graph. So here it says, analyze the graph to address the following about the quadratic function it represents. This is on page 290 in your guided notes. It says, what is the value of the leading coefficient? So to figure that out, I can take the vertex form and I can substitute the known values and solve for A. So I should know everything but A. I know H and K. That's going to be -1 and 4. I even know X and Y because I'm provided a point on the graph, so I can use 0 and 3 for that. So if I substitute those known values, my vertex form becomes 3 equals A times 0 plus 1 squared plus 4, and I just got to solve for A. So to solve for A, we need to be able to simplify and get the A by itself. So subtract 4 from both sides. That becomes -1. Bring this down, and this is just A times 1. So now I can see that the value of A is -1. And that should make sense because that means that the parabola should open downward, and in fact it does. And then I want to take that information, and now I can take this information and I can write the vertex form, because now that I know A and I know the vertex, I should be able to write the equation. And so that's what this represents. Here's my vertex form. I know the value of A. I know the value of the vertex. I just plug that information in, and this is the equation in vertex form. And I can go from that equation and I can write the equation in standard form. Standard form will be this one, ax squared plus bx plus c. And in order to do that, I take my vertex form equation and then I just solve it. I want to simplify it so that there's no parentheses. I kind of break that up and I get it as close as possible to look like this. So in this standard form, there is no parentheses, so I want to get rid of that. So that squared tells me that I need to separate this out. So x minus 1 times x minus 1. And I can use FOIL. So x times x times -1, -1 times x, -1 times -1. And then I can distribute that negative sign to each one of these terms. And I can simplify. So these can be combined, right? -1 and 4, those can be combined. And so this is my equation that is in this form, right? Standard form of a quadratic function. -x squared plus 2x plus 3. And then from there, this is my y-intercept if I replace this and this with a 0. So it should match. And so that's everything in your notes. I know that video was a little longer than normal, but everything we need to cover for section 4.1. I want you to bring this to class so then we can look at your homework.